One of the things I need to find out here sooner rather than later, because I'm getting close to getting ready to scrape the ways on the table, I need the saddle to be ready. And right now it was one of the first things I scraped. It's parallel, flat. The bearing quality is not really great, but with the amount of material that's been taken off to get square and straight, I need to add turkite to the saddle. And what I want is, if I'm going to add turkite, I want to do it in a way that I put everything back so that all the handles and all the lead screws are in good alignment. So now I need to figure out basically I need to figure out where I want the yoke to be in relation to these ways, which then puts this in relation to the saddle. So I'm just using the bolt holes for now, which is not ideal, but it should work. I mean, we're talking bolt hole clearances in the end caps anyways, so I'm just picking up the center, the center line of these two bolt holes. I'm going to pick that up relative to this surface here, and then I'll translate that into the distance between this surface and the bore for the lead screw. So I've got the indicator zeroed on the plate with the vernier on the height gauge at 0, and then I'm using the bolt zeroed again, and then I'll just take that height off the vernier. I had an aha moment, and basically with the end cap on the table now, really all I got to do is pick up the bottom of this bore. I use the telescoping gauges. This bore is 1" 850, so we'll take half of that. We already know the height to the ways here, so we just got to get the indicator in here and get zeroed out down at the bottom of this bore, and then we'll know exactly the difference between these two positions here. That was a lot easier than figuring out hole patterns and where these holes were in relation to these. Anyway, sometimes these things come to you. So at that point there, that's the bottom of the bore. The indicator is going up on either side. So now we just take that measurement off the vernier on the height gauge, and we'll know where the bottom of that bore is. So with the bore diameter being 1" 850, the height from the surface plate to the bottom of the crank handle bore was 2" 932, and the height to the ways, and I measured that in the center at the worn position, so the two ends are going to come down to that, which is 2" 711. So to solve for our height here between the bottom of the ways and the center of the bore, It's 2" 932 plus half the diameter minus this distance here, so we end up with 1" 146. So that's our center line to the x-axis ball screw, or not ball screw, lead screw. And so now we just got to do the same kind of thing with the saddle and figure out where the center line of the yoke is for the saddle. Measurements on the saddle. I've got the yoke bolted down. I've got my test bar in the yoke, so that's picking up the center line of this. This would be the x-axis nut, so that's picking up the center line of that. I've got this. It's actually a piece of 3/4 stock. It's I checked it on the surface plate. It's relatively flat. I don't know what it was just something I had picked up in some scrap or something somewhere. And then conveniently it's got holes in it, so I'm just gonna drop down in and measure the depth from this surface down to the test bar. We know the radius of the test bar, we know the height of this, and we'll do a little math and we should be able to figure where we're at. So that's 1" 1" 080, and then we got to do a little math to figure out where the center line is. So in this setup here on the saddle, what we're looking for is from the top of the ways down to the center line of the bore, which I'm calling height 2, which is going to be the 1" 080. That's the measurement we got down to the top of the test bar. We got to add the 781, which is the radius of the test bar, and then we got to subtract the 750, which was our bridge there. So our total there is 1" 111 thou. And we were 1" 146 thou on the measurement on the table. Which means we are 35 thou low. And I think we said we were 45 thou on the saddle on the bottom ways as well. So, I mean, that's not ideal, but what I'm shooting for is when this goes back together, that the handles, all the lead screws line up, and I don't have any issues with. I don't want to slot holes. I don't want to move things. Trying to get it back together, which helps with the fitting of the gibs as well. So that's where we're headed. We're going to put 45 thou on the bottom of the saddle and 35 thou on the top, and then we'll scrape them back in parallel. I had another aha moment, and I thought I better put the end caps on. the ones that hold the bearing and hold the lead screw. And good thing I did. So what ends up changing is the actual height here changes to a 2" 955, and then so that equates to this the way height to the center line of the board changes to 1" 169, and I did check both ends and they're within a 5 thou, which is good. That's back on the original dowels, so I don't have to elongate any holes or anything like that, so that's good. I'm happy about that. But what that ends up driving is the delta, which is missing on the saddle, ends up being actually 58 thou, which one of my viewers commented it might as well be a mile at that point. So I'm going to put a fair amount of turkite on the saddle and get it scraped back in. So I've got the saddle back. My friend Harold helped me out. Got turkite on here. The only thing was just a miscommunication between us, mostly on my part anyways, but I was looking for him just to put the turkite on for me, but trying to help me out, and actually in the end it did, right, is he went ahead and they put the turkite on and put the oil grooves in for me, relocated all the oil holes and everything. So, and that's top and bottom. So basically now this thing is pretty much back to the geometry, the dimensions that would have where it would have started life. I think on this bottom side here is I needed to finish 45, so I think there's like 40, 47, I can't remember, but, and then I needed 58 on the top for the table, so I think that ended up being, the material comes in at I think 62. So, and then one of the things that happened, I had not been anticipating and was not planning for the two pads here for where the yoke bolts to. So I had scraped the top and the bottom parallel, and when they checked it, there's an issue with this pad here. It's not parallel to the top or the bottom. So as I go through this again, I really got to go slowly and make sure that I get you know, these two surfaces. This is for the table, and then the back side, I've got to get them parallel. Obviously they both need to be perpendicular to the back side of the saddle, and obviously of course parallel to the fixed way for the table, which is again on the back side. The gib for the table's on the front side of the saddle. So once I get that, and then so this would be parallel to the back, and then this side here, which would be the right side as you're looking at the Bridgeport, this is the fixed way side for the Y travel in and out towards and away from the column, which has to be perpendicular to the back in order for X and Y travel to be perpendicular to one another. So there's a fair amount of work to verifying geometry and getting this piece itself in line, and so in real time right now I'm about 80% of the way through the flatways on the table. So I'm going to get them roughed down, just roughed down for geometry, and then I need to get this ready because I will need to use these two surfaces once they're flat and ready to check the two corresponding ways on the bottom of the table, because they need to be coplanar, and you know, I have to make sure I will be using the saddle as a gauge for my scraping and the geometry on the flatways on the bottom of the table. So a little bit of switching gears. Like I said, I got maybe another hour or so just to get the table in a position where I'm ready to start getting ready to try and get a bearing surface, and then I need to have this saddle ready to go, because I will be using it for spotting in the flatways on the bottom of the table. That's just an update. We're moving along, and then so once all that's all done, then I will have to scrape these two pads. I'm going to take a minimum amount of material off of there because I was using this for measuring turkite application, so I'll need to take just a minimum off of this to get this straight, because you know, if there was 2 thou of misalignment in here at the end of the table at 48, well, I guess 24 inches from the center, that's quite a bit of movement on the screw. So I want to make sure this is good and parallel with the top of the ways here as well. One of the things that I've been trying to find is a new yoke. This one here is in rough shape. The casting's blown out here where the adjusting screw has to go in there. Nothing really wrong in the top bore, but this bottom one's pretty banged up, so I've been searching for it, and luckily I've got a uncle in the furniture business who's taking care of me. This is basically brand new. So one of the things I wanted to do, because I've used this to measure for the turkite, I wanted to make sure what's going on, how far apart are these bores. So off the surface plate the Y is 1.915, and off the surface plate the X is 5.906, so they're 4-inch and 9 thou. I don't know whether I'd be concerned about that 9 thou. I think it's probably supposed to be a 4-inch center line. So what I'm going to do is I'm going to put the new one up and just make sure. Just want to make sure I got a carpet here on the surface plate to make sure I don't damage it. And this backside here, it's not machined on the casting. The bottom is machined here to fit on the saddle, and then what I did with the other one and I'm doing with this one is just checking this surface here is machined perpendicular to this face here. So that's looking good, and then down, just checking underneath of here, making sure I don't have any gap or anything. So it's seated down on there. And then I've got the height gauge set up with the indicator, and I've left this at the higher surface, which should be 5" 906. So that's looking like it's within about 7 or 8 tenths. And so now I'm going to do the same thing on this bottom one. So what I'm doing, I'm actually trying to find the low point on this bore. Which is right there, and then we just got to take that reading off the vernier. Which right now appears to be 1" 9. I'm going to say 906. I'm going to get some magnifying glasses just to make sure on that. So when I measure the new one, I got a 1" 909 on the bottom, which is the X, no, sorry, the Y, and 5" 907, so 4" 2 thou between them, and about 6 thou difference actually on the X, only about 1 thou difference in the position relative to that flange. So I'm gonna call that bang on, and we're gonna go with that. So everything I've done so far on the saddle is going to line up with this new yoke.